Division. It's been a while. Right? What's the first question you ask yourself? 3 times what gets me close to 5 without going over, right? Or
1.
And then you multiply the 1 by the 3 and you put it here. And you subtract. Right? So you get 283. Everyone agree so far? Then you ask yourself, 3 times what gives you 283?
27.
Well, let's, and don't you just kind of do the first part, right? Like maybe the 28. So 9, oh, you did that. So 9. So 9 times 3 is 27. I'm going to put a, and you get 13. And then you say 3 times what gives you something close to 13?
Oh.
And 3 does not go into 1, so that is our remainder, correct? There are a couple of things we could say about this, although this is probably beyond what we need for today. But we could say that 583 divided by 3 is 194 and 1/3. Right? We have 1/3 left over. There's a couple ways you could do that, but that's just long division back a long time ago. Why would we review long division? Because no, I'm not about to make you start dividing without a calculator. We're about to do it with polynomials. Y'all remember doing polynomial division last year? There are 2 ways to do it. Did y'all learn synthetic division with the little boxes and stuff? So that's one way to do polynomial long division. I'm going to show you both. The reason I did the regular long division problem is we can kind of follow that process. I'm going to ignore this 7. Very much like if you had 31, you would kind of ignore the 1 and think about 3 into something just to make your brain easier. I'm going to ask x times what gives me x squared? Well, x times what gives me x squared? X. That goes here. What do I do next?
Wait, is there another way to do this?
Synthetic division, yes.
Are we going to learn that?
Yes. But synthetic division does not work for everything.
You're right.
So long division is a little bit more important probably because it works for everything. And I don't know if we'll actually get to synthetic today or not. We may just do long division today. We'll see. We only got 30 minutes today. So. Okay, what did we do next with the 1 and the 3 on that next step? Didn't we multiply them together and put it down here? Mm-mm. So I'm going to multiply the x times the x minus 7. I'm going to multiply these and put it down here. Well, x times x minus 7 is x squared minus 7x. What was my next step? Subtract. Here is star this place in your notes. Most people who mess up long division do it right here. I do need to subtract everything, which means I need to change the sign on both of them. Be careful about that. A lot of people forget to subtract the negative 7x. They end up adding it. So be careful about that. Change the sign on both. X squared minus x squared is 0. Negative 3x plus 7x is 4x. Okay, any questions so far? I'm going to go ahead and bring down the 10 just like I did on the others. And then what? What did I do over here with the 3 and the 283? The 3 and the 28. You did 3 times what gave you 28, right? So I'm going to do x times what gives me 4x. 4. Let's do a different color so you'll see we're in a different spot. Okay, and then I'm going to do what next? Multiply the 4 times the x minus 7, and what do I get? Minus 28. The 4 multiplies by the x and the 7. Subtract, and we're going to be very careful on this step to do what? Change the signs on both. The 4x's cancel. If you are not, if the 4x's aren't canceling, you did it wrong. Those will always cancel on polynomial long division. 18. Does x multiply by anything to give you 18? No, so this is the remainder. So x plus 4, remainder 18. Done. How many of you, now that we did it, remember doing polynomial long division? It's been a while, but no? Is it as bad as you remember it being? Isn't it really the same thing as we did over here? Same exact steps, just with some x's in them. So let's try this one. Now, again, I don't think I'm going to do synthetic division today, just because we won't have time today and we need one option that works. But I will tell you that synthetic division would not work on this. Because synthetic division, the box thing, if you remember doing that last year, it only works when your divisor is x plus or minus a number, and that's it. So this time the divisor has an x cubed in it, and so it wouldn't work. This is a particularly hard problem, about as hard as I could come up with. There, you don't have to do this, but I am going to put placeholders in. This is an option. Some of you could get away with doing this without placeholders. What I mean by placeholders is you see how this skips an x to the 5th? I'm going to put 0x to the 5th in. Those are not a requirement, but for some of you it will help. This looks like it's going to be way harder, right? What's the first thing I'm going to do? What am I going to ask myself? X cubed times what gives me x to the 6? Well, x cubed times what? Times x cubed, because you add exponents, right? Then I'm going to multiply the x cubed by both pieces. So I get x to the 6 plus 3x cubed. I'm going to go all the way down here to write that. Why would I do that? When I add and subtract, I can only add and subtract like terms, right? So I need that to be next to something I can actually put it with. So I'm going to subtract both pieces. Remember, I do have to change the signs of those. The x to the 6th cancels. The x to the 5th is 0. So the first thing I'm going to write down is the 2x to the 4th. Minus 3x cubed plus 0x squared plus 6x. If you are really good at not combining things that aren't like terms, you wouldn't have to have placeholders. But if you accidentally stack this under the 2x to the 4th and you would add those together, then do the placeholders. So you probably know yourself a little more than I know you on whether you need those placeholders or not. Does everyone see what I mean by that? They're just there to keep you from adding unlike terms together. What's my next step? X to the fourth times what would give me 2x to the fourth? 2x. Multiply that down. 2x times x cubed would give me 2x to the fourth, as I had hoped. And 2x times 3 would give me 6x. Any questions? Again, why did I put the 6x way over here? To put it with a like term so that when I subtract, I do that correctly. Change both sides. Putting what to the side? And she may not have last year. She may have just had you stack it under here and then not add the 2x, right, do 2x to the fourth minus 3x cubed because they're not like terms. So she might not have had you do placeholders. And it's okay. It's not wrong. You wouldn't, again, you wouldn't have to. But to me, a lot of you might accidentally, if you stack that underneath the 2x to the fourth, might accidentally try to call that -1 x to some power. I'm not sure what power you would pick, but it happens, so this is just a way to avoid that. The x's cancel, and I'm going to go ahead and write 0x, though. Even though that's silly, I'm just going to go ahead and keep that placeholder. And the last one, how do I know it's the last one? It's cubed, right? Anything below a cube, it's not going to go into. X cubed times what gives me -3x cubed? -3. -9. Change both signs. And what do I get? 0. So that one went in evenly. There will be some important things with ones that divide in evenly. So that is how you do polynomial long division. Any questions about that? Okay, this should pick up, am I right now? All 1 through 30 is doable. 1 through 30 on that toolbox. Okay, we're going to start the next lesson. If we don't finish it, we'll finish it on Monday. Remember, Monday for you is kind of we may have, as long as we finish this, we'll have a work day. Whatever we don't finish, we'll finish. Also, Monday, don't forget, y'all really need to start hitting that mastery test hard, because I have a lot of you who haven't. It's due next Friday. So you've already had a week, and I've got maybe 4 of them in or something like that. So I need you to start mastery testing. So it would be wise if you did all your homework before Monday so that you could just sit mastery test Monday. Okay. Quiet. Okay. We're going to be looking at polynomial functions. That is Unit 6. Polynomial functions is Unit 6, and that's our next unit. Polynomials aren't the hardest functions in the world to work with, especially when you have a calculator. So they are nice to work with. And this says estimate the x-intercepts, and it puts parentheses, zeros, and roots. What are x-intercepts, zeros, and roots? They are all the same thing. What are they? So if you know one of the words, you know the answer. What's an x-intercept? Like, what is it? If you were looking at a graph, what is an x-intercept? Where it crosses the x-axis. Now, ACT, college algebra final, all of those things, a lot of people miss these questions even though they know exactly how to find x-intercepts. So what you need to know is that these questions mean the same thing as x-intercepts. Roots and zeros of an equation are the same thing as x-intercepts. So write that down in your notes if you didn't know that. Zeros, roots, x-intercepts, all the same thing. So it says estimate the x-intercepts from the graph. We do have to estimate. What do we have? What are the estimates? Okay, 1. I think 1 is a good one. 0 is a good one. 0.5 or 0.6, okay. And negative 1.6 or negative 1.5. Any questions about how we got this? Now, would you be wrong if you put 0.5 instead of 0.6? No, that's just what Chris said, so I said sure, sounds good. All right, negative something, 1 and something. I guess they just didn't pick it up yesterday. Yeah. If they asked for it, I'll have it. Okay. A polynomial function. Y'all listening? A polynomial function is one that looks like this. Now, that looks scary, so we're going to take the scary out of that. All of the a's are just constants. The x to a power, so an example of a polynomial, quiet, you need to listen. 3x cubed minus 2x squared plus 5x minus 1. This is a polynomial. Okay? It says n is a non-negative integer, so the powers are never negative, and they're integers. What is an integer? Actually, we could simplify it by using a different word than integer, but we'll go with it. What is an integer? Is a whole number. Whole number that could be negative, but they said not negative, so better word for this would be the powers are whole numbers. So it's not fraction exponents, not decimal exponents, not weird exponents. Yes. So a polynomial, something that looks like this, where the powers are whole numbers. And the coefficients are real numbers. They don't have to be whole numbers, they just have to be any real number. So they're not imaginary numbers, but they could be anything other than that. We can name polynomials in 2 ways. And a lot of times I hear you get these confused. You know a lot of these names, but sometimes we don't know where they're coming from. We can name them by the degree or by how many terms they have. The degree, what is the degree from your other work you've been doing? Good. What is the degree from your toolbox work? The biggest exponent. So we can name it by the biggest exponent, or we can name it by how many terms it has. A constant is technically a polynomial. The degree of it is 0. It's x to the 0 power. If you were to really want to write an x there, it would be x to the 0 power. This has 1 term. What that means is 6 is just one thing. So that's called a monomial. It has 1 term. If the degree is 1, so x to the first power plus or minus something, that is linear. Now this particular one has 2 terms. Does everyone see that? 2 terms is called a binomial. You've heard me use the word binomial before. When I say, how do you multiply binomials? And then we say FOIL. Binomial is something with 2 terms. Do these words sound familiar? If the degree is 2, what is that called? Anyone remember? It is a square, but what's the function called? We spent a whole chapter on them. X squared plus 3x minus 2. Something like that. Do what? Starts with Q. Quadratic. So a quadratic function has a highest power of 2. This is an example of a quadratic. This particular quadratic only has 1 term, so it's still a monomial. You see how it's a little different based on degree or number of terms? Some quadratics have 3 terms, and those are called trinomials. So the number of terms is this naming, and the degree is this naming. Degree of 3 is called a cubic. Degree 4 is called a quartic, and degree 5 is called a quintic. You will never be asked anything above a degree 5. You probably won't even be asked anything up to a degree 5, but you will never be asked anything past a degree 5. Anything above a trinomial is just called a polynomial. What does the word poly mean? Many, right? So polynomial means many terms. So if there's more than 3 terms, we will quit calling it binomials. Trinomials, let's call it polynomial. If you want to be specific, you see they called it a polynomial of 4 terms. So those are some names of polynomials. Any questions about these names? How many of you knew some of these already? Before, good. Okay, standard form of a polynomial is with the highest power first, written in decreasing order. So if it asks for standard form, highest power first, decreasing order. So let's look at this one. What should I write first? X cubed, but what's with it? The negative signs always go with the thing it's in front of. So it's negative x cubed plus x squared plus 4x minus 3. That is standard form. If I want to classify it by its degree, what is it? Cubic. And by the number of terms? Good. Polynomial 4 terms. It's not a trinomial or a binomial. It has more than that. So it's polynomial of 4 terms. Any questions about that? Would it be hard to make the classification before you wrote it in standard form? Yes, especially this next one. Now you could probably pick out the highest power, but how many terms does it have? At first glance, I'm not sure because I have some things that can combine. What's the first thing I need to do? with parentheses like that. Distribute the negative. The negative goes with the 7, the 4, and the x squared. So now I have x squared plus x squared, which is 2x squared. I have negative 3x and negative 7x, which makes negative 10x. Positive 5 and positive 4, which makes 9. Now, based on its degree, what is it? Quadratic. And how many terms? So what's that called? How do I do this next one? What do I have to do on it? No. How do you square a binomial? FOIL. We've been asked that question before, haven't we?
Hey,
Yes.
send type short to the office at Bell.
Okay. Any questions so far? FOIL. So I get x squared minus 2x plus 4 x to the 4th. This is negative 4x, right? Negative 4x cubed. I'm going kind of fast. Any questions about how I'm getting this stuff, though? Distribute. So it is a quartic and a trinomial. Any questions about how to do that? We have a little bit more work to talk about. You might could figure it out based on looking at the book, but if not, I will talk about that on Monday. This homework is also due Tuesday. Page 424, 5 through 10, 17 through 20, 29 through 32. Due Tuesday, along with the toolbox. It should be done Monday, but I'm going to grade both of them on Tuesday. Partly because my 6th hour I'll be Monday. Y'all are kind of benefiting from, yeah.